Hi students, today we are going to see a last sum in the third concept, right? Last sums. Totally we are having 11 sums. Sum number 11, right? So this is also very important sum, right? Mostly they are repeatedly they are asking this question, right? So okay, DEF are the midpoints of the sides BC, CA and AB respectively of triangle ABC. Determine the ratio of the areas of triangle DEF and triangle ABC. First you can draw the triangle ABC and DEF are the midpoints of BC, AC and AB. By joining these three midpoints, we got a triangle, right? Now they ask you to find the ratio of the area of triangle DEF and triangle ABC. Triangle DEF and triangle ABC. So only the given is something but DEF are the midpoints. DEF are the midpoints. So we want to find the ratio. So how we are going to find? Very easy, right? Given DEF are the midpoints of side BC, CA and AB respectively, to find area of triangle DEF divided by area of triangle ABC, right? Okay. See, D is right. D and E are the midpoints on the side BC and CA respectively of triangle ABC. Then we can say that, right, by using the midpoint theorem. See here, D and E is the midpoint of side BC and AC. Then we can say that DE is parallel to AB. DE is parallel to AB. If DE is parallel to AB, surely DE is parallel to AF. DE is parallel to AF. Take it as equation number 1. So when this will be parallel? When we are having two midpoints, right? D and E are the midpoints of sides of a triangle BC and AC, right? The triangle we are having three sides. Among that, in the two sides we are having in the midpoint, while we are joining the two midpoints, what we will get it? We will get a parallel line, right? Last year itself we have studied that, right? Midpoint theorem. So DE is parallel to AB. If DE is parallel to AB, surely DE is parallel to AF. AF is nothing but a part of AB, right? So take it as equation number 1, right? Next, D and F are the midpoints of side BC and AB. Then DF is parallel to AC. DF is parallel to AC. At the same time, DF is parallel to AE. Take it as equation number 2. From equation 1 and 2, DE is parallel to AF and DF is parallel to AE. Then we can say that AFDE is a parallelogram, right? So DE is parallel to AF and DF is parallel to AE, right? Then we can say that AFDE is a parallelogram. AFDE is a parallelogram. Take it as equation number. AFDE is a parallelogram. Similarly, right, while we are taking the same midpoints, similarly we'll prove that BDEF is a parallelogram, right? BDEF is a parallelogram because D and F is a midpoint and E is also midpoint. By using the same midpoint theorem property, right? Midpoint theorem property, we can prove that. But I'm just putting similarly. BDEF is a parallelogram. BDEF is a parallelogram, right? Now I'm just going to prove that. I'm just going to take the two triangles, right? I'm just going to take two triangles, triangle DEF and triangle ABC. I'm just going to prove that these two triangles are similar. If these two triangles are similar, then we can, by using the statement of area ratio theorem, we can find the ratios. So in triangle DEF and triangle ABC, angle A is equal, right? In triangle DEF and triangle ABC, angle A is equal to angle D. These two angles are equal because now only we prove that AFDE is a parallelogram. Opposites angle of a parallelogram will be equal. So angle A is equal to angle D. That only. Angle FDE is equal to angle A. Opposite angles of a parallelogram AFDE. Same like that. Angle DEF is equal to angle B, right? Angle DEF, right? Angle DEF. That is, this angle will be equal to angle B. Angle B. In this parallelogram, right? FBDE parallelogram, angle B is equal to angle E. Opposite angles of a parallelogram will be equal. So by AA similarity rule, right? By AA similarity rule, triangle DEF is similar to triangle ABC. Triangle DEF is similar to triangle ABC. So area of triangle DEF is equal to DEF divided by area of triangle ABC is equal to, I'm just choosing only one side alone, right? DE and AB alone I'm just choosing, right? DE square divided by AB square. DE square divided by AB square. See, if F is a midpoint, right? F is a midpoint, then we can write it as, how we can write it as? We can write it as, if F is a midpoint, then AF is equal to FB, right? Already we have proved that FEDB is a parallelogram, right? FEDB is a parallelogram. So DE is equal to FB, both are equal. If these two are equal, then we can say that these two are equal. So how we can write? AB is equal to 2 times of DE. Shall we write? Why we are changing in terms of same variable means, then only it will be easy to remove the variable. That's why I'm just converting the variable into the same variable, right? So DE is equal to DE, right? AB is equal, right? AB is equal to 2 times of DE. AB is equal to 2 times of DE. How? Because F is a midpoint. So AF is equal to FB. Already we proved that FBDE is a parallelogram. So FB is equal to DE. Therefore, DE 2 times of DE. AB is equal to 2 times of DE. So I substitute instead of AB, so I substitute 2 times of DE, 2 times of DE, right? So apply the square. So 4 DE square. DE square will get cancelled, right? DE square. So 1 by 4. Area of triangle DEF divided by area of triangle ABC is equal to 1 by 4. That is 1 is to 4. The ratio of the area of this two triangle is equal to 1 is to 4, right? That's our third concept is over, right? I think so. The third concept, right? Among that, third concept is very, very easy, right? We are having only one property, right? We are having only one property, only one statement alone. With the help of the statement alone, whatever they are asking, we are finding or we are proving, right? For that, we are having some conditions. First, we are satisfying the condition. Then only with the help of the property or with the help of the statement, we are finding. Understood, right? The next concept is something about Pythagoras theorem. And this is the last concept, right? In this concept, we are having two theorems, Pythagoras theorem and converse of Pythagoras theorem. But converse of Pythagoras theorem has been deleted, right? So this year you don't have a converse of Pythagoras theorem. Only we are having a Pythagoras theorem, right? And this is very, very easy and very interesting theorem, right? So with the help of the property of Pythagoras theorem, we are going to find that we are going to prove whatever they are asking, right? So first we will see the theorem, right? So Pythagoras theorem or Bauduin theorem, right? What is the name of the theorem? Pythagoras theorem or Bauduin theorem. Statement: in a right triangle, right? In a right triangle, the square of the hypotenuse, here what is hypotenuse? Opposite to the right angle, the side opposite to the right angle is called hypotenuse, that is AC. The square of hypotenuse, that is nothing but AC square is equal to the sum of the square of the other two sides. So other two sides AB and BC, square of that is AB square plus BC square. Why plus? Sum of the, right? So what is the statement? In a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Sum of the square of the other two sides. That is given is nothing but triangle ABC, right? Triangle ABC is a right angle triangle, right? Right angled at B. That we are taking, right? So the given is nothing but a right angle triangle. In a right angle triangle, that is the given, right? So we want to prove that if a triangle is a right angle triangle, right? Right angle triangle, then we want to prove that the square of the hypotenuse is equal to the sum of the square of the other two sides. That is, see, AC square is equal to ABC is a right angle triangle, right angled at B, then we want to prove that AC square is equal to AB square plus BC square. AB square plus BC square, right? So we want to prove that AC square equal to AB square plus BC square. How we are going to prove that means it's very simple by using that similarity property, right? The similarity property. I'm just going to choose we are having three triangles, right? See, I'm just going to construct a perpendicular line. Draw BD perpendicular to AC. Draw BD perpendicular to AC. So now we are having three right triangles, right? ABC is nothing but one right angle triangle. ADB is one right angle triangle. BDC is one right angle triangle. We are having three right angle triangles, right? So I'm just going to take two right angle triangle, and I'm just going to prove that these two triangles are similar by AA similarity. If these two triangles are similar, then what is it? What we'll say? We'll say that the sides are proportional. So if the sides are proportional, then we'll do the cross multiply and we'll bring this AC square is equal to AB square plus BC square. Understood? So proof. First I'm just taking the two triangle. Triangle ABC and triangle ADB. Right? Triangle ADB. I have chosen two triangles. The first triangle is nothing but, once again. So from this triangle, I'm just taking the two right triangles, right? ABC is one right angle triangle, and ADB I'm choosing, right? ADB, right? So here in the first triangle, middle letter is nothing but right angle. Same thing. The second triangle also, middle letter is nothing but right triangle. So you have to take the variables correctly, right? That's why I'm just repeating, right? So ABC, here we are having A, right? A is nothing but common angle, so I'm just writing the first letter, right? So ABC and ADB, ABC and ABD, angle A is equal to angle A. These two angles are equal, right? Angle A is angle A equal to angle A, common angles, and angle B is equal to angle D. Angle B is equal to angle D. Each 90 degree. So by AA similarity, these two triangles are similar. If these two triangles are similar, then the sides are proportional. AB by AD is equal to BC by DB is equal to AC by AB. Among the three sides, right? Three sides are proportional. Among the three sides, you just see that the one variable alone will be repeated twice. You have to choose the two ratios alone. See that AB by AD, AC by AB, AB repeated, right? AB repeated. You just choose this two alone, right? So AB by AD is equal to AC by AB. Just do the cross multiply. AB into AB, and taking this AD to the RHS. AB into AB is equal to AD into AC. AB into AB is nothing but AB square is equal to AD into AC. Take it as equation number 1. Take it as equation number 1. So first I have chosen the full triangle with this second part of right angle triangle. Next once again I am just going to choose a full triangle and this second triangle, right? Second right triangle, small right triangle. So it is nothing but ABC, right? Triangle ABC and triangle BDC, right? Triangle BDC I am going to choose, right? So triangle ABC and triangle ABC and triangle BDC. Here, which triangle will be equal? Which angle will be equal? See, we have chosen two triangle ABC and triangle BDC, right? So angle C will be common for both the triangle. Angle C will be common for both the triangles, right? See, B also common, but B is dividing, right? Not a full angle, half angle alone, right? In triangle BDC, see in the triangle ABC, angle B is 90 degree. But in triangle BDC, it is not a 90 degree, right? So we can't take a B angle. Only we have to take the angle C angle alone. C is the common angle for both the triangles, right? So angle C is equal to angle C. Angle C is equal to angle C. These two angles are equal, right? These two angles are common. So common angles. Angle B is equal to angle D, each 90 degree. So by AA similarity, these two triangles are similar. Which two triangles? Triangle ABC and triangle BDC. So while you are taking triangle BDC alone, you want to take. Suppose you are taking CDB means, then you won't get a correct answer. You have to take correctly, because see in the first one you have taken the C C is in the common angle, right? C is in the common angle. In the first triangle I have taken as a third variable. The second triangle you have to take it as third alone. If you are taking as a first variable, then you will get a wrong answer, right? You can't get a proof. You won't get a correct proof, right? So you have to write it correctly. See, so C you have to in the C is in the common angle, that should be in the same place alone, right? ABC, BDC. Here also B is in the right angle, D is a right angle. So everything is in a correct order. So now you can write, if these two triangles are similar, then the sides are proportional. AB by BD is equal to BC by BC divided by DC is equal to AC by BC. Now compare the three ratios, which among the three ratios, any two will be the same variables, same sides or same variables, same sides. So it is nothing but, which one will be? BC, right? BC and BC, right? So these two are having same variable. So just take that. BC by DC is equal to AC by BC. Just do the cross multiply. So what will get? BC into BC is equal to AC into DC. So BC into BC is nothing but BC square. BC square is equal to DC into AC. Take it as equation number 2. Now just add equation 1 and 2. What is the LHS of equation 1 and equation 2? AB square plus BC square. AB square plus BC square is equal to RHS. AD into AC plus DC into AC. AD into AC plus DC into AC. So what is the common term? AC is common. Just take commonly outside. What you will get? AD plus DC into AC. AD plus DC into AC. What is AD plus DC? What is called AD plus DC? AD plus DC is nothing but AC. So I write instead of AD plus DC, shall I write AC? Okay. So instead of AD plus DC, I have written AC. AC into AC is nothing but AC square. So we have what we want to prove. AB square plus BC square equal to AC square. Hence it is. Understood? And this theorem is very easy and as well as very important theorem. Surely we can expect for our exams, right? Public exam. Surely we can expect for our public exam. So today itself, thorough this theorem and you have to write 5 times and you have to send it to me, right? Don't forget. Based on this statement, we are going to find or we are going to prove, right? So what is the condition? What is the condition? For what condition we will use this statement? If the triangle is a right angle triangle, then we will use this property. What is the property? If it is a right angle triangle, then the hypotenuse square is equal to AB square plus BC square, adjacent square plus opposite square, right? Hypotenuse is nothing but always opposite side to the right angle. Understood? So AC square equal to AB square plus BC square. That's very important, right? So in the right angle triangle, that AC is nothing but opposite side to the right angle. That's very important. Opposite side to the right angle. Understood? Okay. Now we will see the sums based on this property or statement, right? Concept 4, sum number 1. Sides of some triangle. This is 1 marks alone, but okay, we'll see. Sides of some triangle are given below. Triangle are given below. Determine which of them are right triangle. So we are going to check whether the given sides are belongs to right triangle or not by using the Pythagoras theorem, right? So they have given the measurement 3 cm, 8 cm and 6 cm, right? So first subdivision, I have drawn the diagrams, right? So among the 3 measurements, right, what is meant by hypotenuse side? What is called hypotenuse side? See, in a triangle, right, in a right triangle, right, the biggest side is called as a hypotenuse, and the opposite side to the opposite angle to the side is nothing but hypotenuse, right? So if we are having 3 measurements, if we are having 3 measurements, 3 sides of a triangle, right, among the 3, only one alone, right, that alone will be a biggest one, that is called as a hypotenuse, right, the side of a hypotenuse. So here 8 centimeters is the hypotenuse. So I have drawn the triangle ABC and I have marked angle B as a right angle. That means hypotenuse is nothing but AC. So AC is equal to 8 cm. Right? The remaining will be wherever you can write it. If you want to write AB is nothing but 3 cm and BC is equal to 6 meter, no problem. Suppose if you want BC is nothing but 3 cm and AB equal to 6 cm, that is also no problem. Right? Whatever you want, you are needed, you can write it, no problem. But the hypotenuse should not get changed, right? That is very important, right? Okay, I'm just assuming that let ABC be a right triangle. Then by Pythagoras theorem, AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. So here AC is nothing but 8. So 8 square is equal to 3 square plus 6 square. Actually, I have written AB is 3 and 6. No problem. You can change it. Whatever you can write, no problem, but I have written already, that's why I'm just changing. So AB is nothing but 3 cm, so 3 square, BC is nothing but 6 square. So 3 square, 8 square is equal to 64, is equal to 3 square 9 and 6 square is nothing but 36. So 9 plus 36 is equal to 45. 64 is equal to 45. Both are equal? No, not equal. Therefore, triangle ABC is not a right angle triangle. Not a right angle triangle, right? Second subdivision, you can take it as a homework, right? 7 cm, 24 cm and 25 cm, right? You can draw a triangle. Among these 3, which is the biggest one, that is called hypotenuse. The remaining 2, you can fill it, and by using the Pythagoras theorem, you want to check whether the given measurements or given sides are the right angle triangle or not, right? Next, sum number 2. ABC is an isosceles triangle. ABC is an isosceles triangle with AC is equal to BC. This is given. ABC is nothing but isosceles triangle. At the same time, which side is equal? AC is equal to BC. And one more thing is given, if AB square equal to 2AC square, prove that ABC is a right triangle. Prove that ABC is a right triangle. A very simple question, very simple one. One mark or 2 mark, right? No, 2 mark, because they ask you to prove that. No, it's 2 marks. Okay. So given ABC is an isosceles triangle and AC is equal to BC, AB square is equal to 2AC square, right? 2AC square. We want to prove that ABC is a right angle triangle, right triangle, right angle triangle. Okay. Proof. ABC is an isosceles triangle, AC is equal to BC. What is the given? AB square is equal to 2AC square. I am just split up in that 2AC square as AC square plus AC square, right? Instead of this AC, shall I substitute BC? They have given AC is equal to BC. Shall I substitute BC? So AC square plus BC square. So AB square is equal to AC square plus BC square. So when this will be applicable? When this will be applicable? When a triangle will be a right angle triangle. Therefore, triangle ABC is a right triangle. Right angled at C. How I am saying this is right angle triangle? Actually, I didn't draw the diagram. But I am saying that triangle ABC, that angle C is nothing but right angle. How I am saying? Very simple. Hypotenuse side, right? See the hypotenuse side. So hypotenuse side is something but AC, right? In the triangle ABC, AC is hypotenuse. Then what is it? Angle B is a right angle. Angle B is a right angle. Same like that. Here AB square is equal to AC square plus BC square. So AB is something but hypotenuse, right? AB is something but hypotenuse. So which variable is missing? C. Therefore C is a right angle. In a triangle ABC, C is a right angle. Understood? Right. Okay. And today homework is nothing but study thoroughly and write the theorem 5 times, right? That is very important, and that is very important theorem. Don't forget it, right? Thank you.